Morning everyone. I just wanted to do a little breakdown of what goes into the two written exams that you're going to do at the end of the second year of the A-level course. So I'm going to go into the content that goes into each exam, how long each exam is, and I've got a couple of different examples of questions and show you how to break down how to answer them. So first one, paper one, that is 2.5 hours. So there's 120 marks for that one. So that is on technical principles. So overall, that is worth 30% of the overall A-level uh, mark, and it's a mixture of short and extended answers. So short answers are 1, 2, 3, 4 marks, and then extended answers are 6 marks up to 12 marks. You did used to have 28 marks, but they no longer have that on the new spec. So the content that can come up on paper one is on the screen now. So metals, timbers, polymers, papers and boards, composites, smart materials, test materials, stock forms, enhancing materials, timber processes, polymer processes, metal processes, joining materials, adhesives, paper processes, finishes, scales of production, CAD/CAM, product analysis, inclusive design, health and safety legislation, intellectual property, designing for manufacture, marketing and communicating ideas. So you may get some questions that are just straight up only metal. You may get some that kind of combine two, so it's metals and metal processes together. It depends on the kind of question you're looking at, but the smaller questions, the 1, 2, 3 markers, tend to be just a specific topic, so smart materials, and the longer ones, it might ask you to compare two different topics together. So compare a metal product with a timber product and then talk about the properties that way. It's also worth noting that on this paper, 15% of it will be maths as well. I'll go into breaking down some of the maths on a future video. So for paper two, so this is an hour and a half, so there's 80 marks available for that. So this is on designing and making principles, so that's 20% of the overall A level. So that's split up into two sections. Section A, which is out of 30, so that is a product analysis style question. So there's up to 6 short answer questions based on like pictures of products that it'll give you. So it'll give you a coloured handout attachment to your exam paper, and it'll give you a couple of different products that you've got to answer questions about, whether it's comparing, analysing, whatever it may be. And then section B is worth 50 marks. So that is commercial manufacturing. So that's a mixture of short and extended answers. And the topics that can come up on paper two are things around user-centered design, ergonomics, anthropometrics, design movements, designers and their work, major developments in technology, social, moral, ethical issues, product life cycle, design processes, product analysis, environmental issues, standards testing and quality control, quality assurance, and again 15% of it will be maths as well. So now we're going to have a look at a couple of different examples of exam questions and how to break them down. So this is from a section A of paper 2. So this is a product analysis question. So it's given us 2 lemon squeezers. So what it says, so for each lemon juicer, compare the materials used and their suitability. So there's 8 marks available for this one. So this could be an 8, 10 or 12 mark question. Just happens to be an 8 mark one. So what I've done there is I put the marking criteria on there for you. So for 8 marks, so you need to discuss the pros and cons of both materials. So you really need to talk about how well it would work, which would be about 2 marks, how it could be made, 2 marks, the aesthetics of each product, 2 marks, and then a summary of your view of it, which would be the other 2 marks. That gets you a total of 8 marks. Anything longer marked questions, if you're comparing anything, if you're comparing or analysing 2 separate products, you need to have a summary at the end of your answer, which is generally worth about 2 marks. So for this one particularly, so you could have talked about the fact that it's an aluminium juicer, so it will not degrade or rust because it's a non-ferrous metal. The polypropylene one is extremely chemical resistant, so you can go in the dishwasher, it can have bleach wiped on it and it won't fade the colour of it. The aluminium juicer is suitable for large scale batch production because you can just do die casting, so you can make it over and over really easily. Same with the polypropylene juicer, it can be mass produced really easily, but it can just be injection molded, so actually you can make more of them faster. The polypropylene juicer will be available in wider range of colours because you can add pigments to the polymer while it's been injection molded. Um, and although the aluminium juicer can be anodized to change colour or have a finish applied to it, um, that then if it gets knocked or scratched, it will affect it. So generally speaking, it wouldn't be. So polypropylene is a thermal insulator, which makes it ideal for washing in hot water dishwashers. Um, Whereas aluminium will conduct heat. So if you put it in the dishwasher or put it in hot water and you grab it afterwards, you'll burn your hand. So it conducts the heat too well. Aluminium is a relatively low melting point, so it's really easy to cast. It's not a problem. It can be machined easily to remove any defects. Uh, Polypropylene is resistant to work fatigue, meaning that it will flex. So rather than like degrading and cracking, it just won't. Uh, Polypropylene can be formed into sections suitable for clip fittings, so you can do it in separate parts and join it all together. So those are examples of the answers that you can give. There are other answers available as well, so that's why it always says at the end of the marking criteria, accept any other valid response. So that's a typical 8-mark product analysis question. So it's given you two products, it's told you what the materials are made from, then it's told you, it wants you to compare them about the materials and their suitability. So you make sure you're talking about their properties of the materials, how it could be made, and things like that. So the next one is a 6-mark question. So 1 million, so this is part 2 of the same question from just before. So 1 million units of juicer 2, which is the polypropylene one, has been injection molded. Suggest how this process can be monitored to reduce the risk of defective products being sold. So there's 6 marks for this. So that means you have 3 valid points and explain it. So the easiest way to do that is 6 points. So split that in half, so it's 3 points, and then explain those 3 points in more detail. So this question is basically asking you about quality control and quality assurance, and how do you make sure that while you're injection molding a product, how do you make sure it's done properly? So examples would be visual checks. So if you're making, say, 200 of them, you check every 25 or every 50 to check that they are okay. Mold markings checked, so you'd make sure that before you are doing anything, the molds are exactly as they need to be. There's no cracks in them, there's no marks in them. Regular mold maintenance, so ensuring that they are updated and fixed properly. Mold temperatures monitored to make sure that it gets to the right temperature and it cools appropriately. Cycle time monitored and adjusted appropriately, so that will be making sure that enough time has gone where the plastic has been melted down, it's been put into the mold, it's been left to cool the right amount of time. Use of Six Sigma to assess acceptable levels of errors, so it's 3.4 units per million. So from a Six Sigma were those steps to how do you ensure as little error as possible in the manufacturing process. Use of mold flow analysis prior to mold design to check polymer flow when injection molding. So that means when you are making the mold first, you would design it on CAD software like Fusion 360 or Creo. You'd make the mold, and on all those CAD softwares, you can do flow analysis where it would check how easily melted plastic would flow into the mold. So 6 marks, quite simple. It's 3 points, and then sort of back those up. So next question. So this is a 4-mark question. So this is now getting to a smaller answer question. So using an appropriate product example, explain how it conforms to the design theory of form follows function. In your answer, you should reference a specific design movement. So if you've already looked at the design movements video, hopefully this will be fresh in your mind, but this is an example where it's giving you a design belief of a specific design movement or a design school, but it hasn't told you what it is. So this is where you're going to need to draw on some previous knowledge. So 4 marks, you get 1 mark for naming an appropriate product, and then 3 other points needed to explain how it conforms to form follows function. So form follows function essentially means that it's a product that works really well in the first instance, and then afterwards it's made to look nice. So examples will be things like the Bauhaus chair or electric toothbrushes. So Bauhaus is the German design school, so their whole belief was form follows function. They were very, very efficient, very well made, a lot of machining. So it's expected that responses may refer to appearance or aesthetics of a product. Better responses refer to lack of automation and a minimalist approach to design. So that's not having overly excessive decorative features on there because it's just not their style. The most famous designer for Bauhaus is Dieter Rams, who had his 10 principles of good design. You could name other Bauhaus designers if you knew who they were. Dieter Ramsey is the most famous one, and he did a lot with Braun, with things like the radio and the electric razor.